Hello, Isabella. I forgot I announced you on Serbian language, so you couldn't understand what I'm saying. I'm sorry
Yeah,
about
that's
it.
right.
So,
No problem.
I just find it out. It's very welcome you came to join us. I hope you're gonna have many interesting things for us to show us now. So.
Yeah, thank you. Thank you for having me. And yeah, now I would like to give you some inside details about our advanced dry hopping system. This might be maybe a bit too big for some brewers, but nevertheless, I would like to share the idea of that dynamic dry hopping system with you, and also would like to invite you to discuss about other dry hopping solutions. So first of all, a quick technical check. Can you see my screen?
Yes, you're seeing it.
Okay, perfect. So we've heard a lot about, actually brewing technology, what GEA can deliver, especially for craft brewers. And if we are talking about craft beer, of course, we cannot forget about dry hopping. And I think all of you know that dry hopping brings a lot of nice and fruity flavors, and customers really like that beer. But nevertheless, we also have some challenges in dry hopping that we see, and this is actually why we've developed advanced dry hopping solution, and I will give you some inside details about that. First of all, I think all of you know dry hopping is a trend that is ongoing since a couple of years, and more breweries are also looking for technologies and equipment that you can really dry hop in a more efficient and way, and to reduce losses. Because if you're throwing in, we heard about 1.5 kilogram per hectoliters, so dry hopping dosage can be very high. And unfortunately, this is often correlated to very high losses. And this is actually where we want to give you a solution how to do that more efficient. If we have a look at influences on the dry hopping aroma, there are a couple of influences. Most of them are on the process side. So this means actually at which temperature you are working, how intense is your extraction. But there are also some things that we can do from an equipment side. And this starts from tank geometry, but this is also about static and dynamic dry hopping. And today I would like to talk about dynamic dry hopping. And it's also about solid separation. We heard from our colleagues from Westphalia that there are some options with centrifuges, and also luckily there are options also to handle high solid loads. But there are also other ways to handle the solids in that process. So the major challenges I want to talk about is extraction efficiency, of course. And the second point is that emptying of the dry hopping vessel in the end. And if we are talking about extraction efficiency, in most dry hopping applications, we are putting in the hops in the tank and leave them in the tank for a couple of days at a certain time, and then try to separate them. But it is also well known that if you get more dynamics in the tank, and that can be pumping or it can be movement of the hops, you get a better contact between that hop oil and the beer you want to extract. And that's exactly what we're doing with our HopstarDry unit. And let me give you a quick overview. What is HopstarDry? So HopstarDry is actually a total skid, and you heard a bit about skids already. So what we are doing is actually having an external extraction vessel, and this external extraction vessel is equipped with an agitator and with a stairway that you can easily access that unit and fill the hops into that unit. And we additionally have a skid where all the pumps and the valve we need for that application are placed on that. This HopstarDry application is fully automated. So this means the only manual step you have to do in the total dry hopping process is loading the hops into the vessel. After that, the total process will take place automatically. So the vessel itself, it's a pressurized vessel, so that you also don't have any trouble with foaming or things like that. And also we have on the top a total gas matrix involved in that skid, so that we can control pressure over the total process all the time. So the vessel is is available in 3 standard sizes, but we also have built smaller ones and larger ones on request. These are just the standardized options. You see they are designed for a bit of bigger sizes. So the standard size we are using is between 200 and 600 kilogram hop pellets per batch. And the vessel is then between 30 and 90 hectoliter. And that's because we have a full hydrated batch to dry hop then. But let's have a look into the details of the process. So the total idea of the HopstarDry process is, on the one hand side, that we'll have a cycle-wise extraction inside that external extraction vessel. And on the other hand side, and this is one, I think, major point of that application, that we keep the hop solids out of the CCT. So that means that the hop solids do not have to be separated in a later downstream process, but do not leave that external extraction vessel. So how do we do that? So the first step, of course, is we need to bring in the hops into that vessel. And you've seen that stairways that is attached to the vessel, and we're manually loading the hop pellets via that platform. And after that, we have a CO2 flush to remove as much oxygen as possible to have the best product quality available in that process later. And then we're starting a cycle-wise extraction of the hop ingredients, and it's mainly oil what we want to get out of the beer here, out of the hops here. And therefore, we are first of all filling the vessel from the bottom with beer from the connected CCT, and it's a hard piped connection between the CCT and that extraction vessel. And as soon as the agitator is covered, we are starting a dynamic process. And this is actually what you can see here on the right-hand side, the elution step. So agitator is on, and this is a specially designed low shear force agitator. I will show you some pictures in a later part of that presentation. And this intense contact between the hop material, which is very quickly solved in the cold beer then, gets out the oil as best as possible and elutes that aroma you want to have in the beer. Now I was talking about we are keeping the hops in the extraction vessel. And how do we do that? And this is actually done by sedimentation. So this means as soon as we have an aroma enriched batch, so this means most of the oil is in the beer now, we want to separate the hop solids. And we are doing this by a sedimentation step. So this means agitator off, and the hop pellets are sinking to the bottom of the vessel. And now we are using some physics, and actually we're transferring that aroma-enriched beer batch by pushing fresh beer from the CCT into the bottom of the vessel in a velocity that is lower than the sedimentation velocity of the particles. So I will show you some details to get a bit more impression about that. So this means the first step is the extraction, as mentioned, this elution. Then we have that sedimentation step, and you see there's a bed of hops on the bottom, and we are pushing beer here. Let me get my laser pointer here from the CCT in the bottom of the tank, and here on the top we are getting out the aroma enriched beer. And what you can see here is an additional fine filter, because I will show you that. A major share of that solid is held back by the sedimentation. So this is approximately 95% is held back by sedimentation. But there's a small share of particles which are actually not really well sedimenting. And therefore we have an additional fine filter here, which is a self-cleaning, rotating fine filter with a mesh of 100 micrometer. We are additionally separating here those fine particles. So this means now we have eluted aroma oil and have washed out that and sent back the aroma enriched batch to the CCT. And now we can repeat that. And normally we are repeating that 4 times. We've done some measurements. After 4 times replacing that beer by a fresh batch, we are normally fine and have actually solved all the oil that is in the hops, and we're done with the process. And now we are coming to the emptying step. And you can see that we have a second outlet, which is designed to be right above the hop sediment in the end. So this means this aroma-enriched batch, which is above, can be emptied. And we can additionally wash that hop sediment here with deaerated water to actually reduce the beer losses furthermore in that process step. And the water can also be used to empty the vessel then. So this means we are filling up the vessel to a certain level with water, starting the agitator and have a homogeneous slurry that we can send to drain or whatever your disposal concept for the hops is. And the last step is actually a homogenization step. And there's one piece of equipment which I have not mentioned yet. We are equipping our tanks that are connected with that HopstarDry system with a liquid jet mixer, which is basically a Venturi principle. And I will give you some insight details also about that. But this is also something that helps us to really have a homogeneous batch with best quality in the end in the CCT. So let's have a look into the details. I was talking about that special designed agitator. This is that a low shear force agitator, which only has that small propeller inside and a housing around that, which is very efficient, and we have very good results in solving the hops in a very quick way. And we do not have much stress on the beer on the other hand side. We have double sieve bottom. This supports the sedimentation, and as you can see, the design is in a way that that we have a platform which is this in the middle, but we have this total way up here and there by emptying the vessel, so we can just use that to empty the vessel more easy. This is the self-cleaning filter system. So this is this additional fine filter for that hop particles which are not sedimenting, and this is actually rotating and cleaning the sieve all the time. And the good point on that is that we are collecting the hop particles in a chamber underneath the filter, and we can send that back to the extraction vessel from time to time to clean the filter, so that we don't have any losses in that process step anymore. I was talking about that jet mixer, which is in the CCT. So this is how that looks like. There's a pipe inside and a nozzle on top. And the total idea is actually that we have a flow in here, and here's a reduction of the diameter, which is actually creating a local under pressure, which is soaking in other parts of the beer from the tank. And this helps us to create a very good mixing effect in the tank, which also supports the natural convection of a tank. And if you have a layering, for example, of aroma oil in the tank, you can totally mix that up. And the good point on that is also we have some breweries who are using that for other effects. So they are sometimes dosing aroma components with the HopstarDry also, as you have that very good option for mixing that tank. So why do we do that with that dynamics? And this is an example of a project, what we have measured a time ago, where we could compare the hop dosage of a classical cone static process. Then they decided to change to a pallet process with static pallets. And in the end, they decided to use a HopstarDry, and we had a chance to follow that by analytics. And it's quite obvious to see that here we could, due to the dynamics in the process, significantly reduce raw material intake in the process. And this was also followed by validation trials. It was an existing product on the market, and we could not find any differences in taste, even though we were using about approximately 30% less raw material compared to the static process. So let's have a quick look at the process time. So the process time actually depends a bit on the size of the HopstarDry we are using. The larger the vessel is, the longer the exchange of the fresh beer takes, as we have to have that low velocity to not break the sediment and be underneath that sedimentation velocity of the particles. But the process times, the total process times, including an automatic CIP and the push out with deaerated water, is approximately 24 to 1 to 2 days. It's actually depending on also the number of cycles you want to have. The good point on that is after that you have already done your solid separation, so the beer is really ready to fill. So you have a stable product here, even if you have any delays in your downstreaming process, this will not influence the product quality anymore. So last point of that presentation, I would like to give you some insights how those products look like. First of all, we have approximately 10 plants on the market right now. We will install the 11th plant in spring. And you can see the sizes of the plant are quite various. So this is something that we really can customize also for your needs. The smallest one is only 60 kilogram. The largest one has 750 kilogram per batch. So this is quite a large application. And if we have a look how they can look like, so this is a very small one with that stairways up there, and this is the control cabinet. And this is a larger one. This has 60 hectoliters extraction tank volume. There's also one detail that you can see here, and this is the agitator can be installed on top or on the side. I can't see that here, but here's the agitator installed on the side because most existing breweries are limited in their space, so we can fit in the equipment there like it fits for your demand. Here on the top, you can see the agitator installed from the side. When we are loading the vessel, it's actually, it looks not very much, but we have a hydration volume of that hop particles, which are up to 10 liters per kilogram of hop material. And as we are using here fully hydrated hop material in the extraction process, this has to be considered in the design phase of the vessel. There's also an option that we install an additional basket. This is especially interesting if you have some alternative aroma extraction material. This can be, for example, wood, or can be something like orange peel or something like that. Material that will not sediment. If you need any advice on that, please just feel free to contact us to find a solution that fits for your purposes. So to summarize that, what can the HopstarDry technology do for you? First of all, the extraction efficiency. I've shared some data with you from customers' trials. So the raw material, depending on what you're really doing there, but compared to a static dry hopping, we can significantly reduce the amount of pellets used, and also the beer losses. They are normally less than 3%. That depends a bit on the hop quality and the hydration volume that we are losing by hydrating the hop pellet material, and the amount of deaerated water we are allowed to use for the washout. But it is normally less than 3%. And if you compare that to classic dry hopping processes, this is quite good. And the product quality is high, as we have a standardized process with a very, very low oxygen intake. And it's completely reproducible what we're doing here. It is fully automated, so this means also we have a reduced workload, and it is quite safe as we have that loading platform, no climbing on the tank and throwing in the hops from the top, for example. So one last thing I would like to share with you is if this Hopstar application is maybe a bit too big for you for your application, and if it comes to very small craft applications, we know that it's maybe a bit too fancy, maybe a bit more, a bit too much automated. We also have a very easy vessel, which is for a very small amount of hops that can be connected manually to your CCTs. And this is actually something, this is more the manual way to do that, and we can flush in the hops with that vessel. This can also be connected to a CIP and a CO2 connection, and has no automation, no solid separation. But if you're interested in something like that, this is also available. And there's some more inside details here of that. And this is also can be combined with, for example, a Craftstar brew house. Okay, so that's all from my side. And of course, I'm available for your questions now. Thank you.
Thank you, Isabel, very much for this nice presentation. I enjoyed it, and you opened some new ideas to me as well. Hope to our friends as well. So if there is any questions, Isabel is here, so you can